going to look at how to perform a hypothesis test for the population mean of paired differences. We're going to do this using the example of screen time for computer versus TV use for students. So here I always need my sample information, so sample mean, sample standard deviation, and then also sample size. I also need what I'm going to use to do my decision making, so what alpha is equal to. If I don't have data where I'm calculating the differences, I have to know how differences were calculated. And then finally, what I want to be able to show. So I want to show that computer time is more than TV time for students in hours per week. So always in step one, we're going to do our identification. So first, we're going to have our population. Here it's just going to be generically all students. And then in letter B, we're going to state our sample, which is here 25 students. And then I like to define my parameter, so it's mu sub d because it's population mean of paired differences. And these always start with mean difference. So because it's mu, it's mean. Because we have the subscript d, it's mean difference. And then you state the two measurements you're taking. So here it's mean difference between computer and TV use in hours per week. And then for our population, which is just students. And then finally, you want to include how the differences were found. So you can say where mu d equals computer minus TV. And this is important because it affects the way that I would interpret the results. So using this notation, I am going to write my null and alternative in step 2. So we're going to start with our parameter, and that was mu sub d. Now we want to see if computer time is more than TV time. For these problems, when you're looking for a difference, your null value will be the same from problem to problem. So we're always going to be interested in 0 as our null value, because if you see a numeric difference that's a value other than 0, it indicates that there is a difference between the two. Also, knowing the direction it is from 0 can tell you which of the two measurements is larger. So here, because we want to show that computer is more than TV time, I expect this to be the bigger of the two, and then TV time would be the smaller. And so then I expect that this is going to be a positive difference, or that's what I'm hoping to show. And so my alternative is going to be mu sub d is greater than 0. And we've learned that in the past, that would make the null less than or equal to. So realize just for independent data, your direction of subtraction is going to be critical when you write your null and alternative. So here, the reason that I have a greater than is because I expected computer to be more than TV, and so I'm hoping to show the difference that I calculate is positive. However, this would not be the same direction had this difference calculation been done TV minus computer, so keep that in mind. Now when you're doing the testing, letter A, just like normal, is a gimme, so the sampling distribution of x bar sub d has the normal distribution. Then you would have how your conditions are met. Remember that this is either because the population is bell-shaped or because you have a large sample size. So here our conditions are met because the population is assumed bell. So remember that large sample sizes are an n greater than or equal to 30, but that is affected by the number of outliers. So then we have a t-test statistic that we'll calculate, and these are actually similar to what we did in chapter 3. It's our sample estimate. So here our sample estimate is x bar sub d minus our null value, but for these problems our null value is 0, so it's x bar sub d technically minus 0 divided by standard error. So it'd be x bar sub d minus 0 over S sub d divided by the square root of n. So for this problem, our sample mean, as stated in the paragraph, is 5.36, and our sample standard deviation is 15.24 divided by the square root of 25. So I come up with a test statistic of 1.76, which will move us into step 4. So in step 4, because we have a t-test statistic, we're using the t distribution, and degrees of freedom will be calculated the same way that we did in chapter 3, so n minus 1. So for this problem, I have 24 degrees of freedom. Remember that that's necessary because it tells us what curve we're looking at. 1.76 is my test statistic, so that tells me where I am. And then my alternative gives me the direction that I'm interested in. So because my alternative was greater than, this is the area. Going second, vars, because we have a t-test statistic, we'll use the t-CDF. And then remember it wants a lower bound, so that was where our test statistic was, and an upper bound, or where the highlighting starts, or ends, and then you have degrees of freedom. So I come up with a p-value of 0.04, let's round to 0.046. So because that p-value is small, meaning it's less than the alpha we have from the paragraph, which is 0.05, we are going to make the decision to reject the null. So then in step 5, because we rejected, we have sufficient evidence to suggest, and then we're going to restate our alternative, but we're going to do it in a way that makes it easy to read. So there's sufficient evidence to suggest that computer use is greater than TV use in hours per week for students on average. So technically, I have included all of the parts of my alternative. I've just written it in a way that's easier to read. So on average deals with the mean part. I have my two variables, so computer and TV. I have my population. And then because I'm directly comparing the two, I don't need to use how the two compare to 0 or how their differences compare to 0. So when you do these conclusions, you still have sufficient based on your decision to reject, or insufficient had you failed to reject. And then you do rewrite your alternative. You just would include all of the necessary parts. So on average, and that deals with the mean, your two measurements, so here it's computer and TV, your population, and then how the two compare. If you directly compare the two, then you don't have to talk about how their differences compare to 0, or also how you calculated the differences.